Let's say you want to solve the equation 4x plus 2 is equal to 18. You probably know how to do that. Subtract 2 from both sides. You get 4x is equal to 16, and then divide both sides with 4. You get x is equal to 16 divided with 4, which is 4. Now let me give you another equation to solve. This time I'll have an x and a y in it. So let's have 4x plus y is equal to 18. You might just be tempted to think, okay, so what if I put x is equal to 4 over here and y is equal to 2? Is that my answer? 4 times 4 plus 2 is 18? Just like this one. Let me just write that down. X is equal to 4, y is equal to 2. Spare a thought. Can there be any other answer for x and y? Can x be, say, for example, 3? Let's say x is 3. 4 times 3 is 12. And 12 plus 6 is 18. Therefore, y is equal to 6. How about x being equal to 2? 4 times 2 is 8. And 8 plus 10 is 18. Are there more answers? And which one of them is right? To find out the answer, let's try and plot this equation on the xy coordinate plane. Let's say this is the x-axis and this is the y-axis. If you change this equation in the y is equal to mx plus b form, so the y stays on this side, you take the 4x on the other side, it turns out to be y is equal to negative 4x plus 18. This 18 is the y-intercept, therefore the straight line cuts the y-axis at this point, which is 18 units above the origin. And then the slope of the straight line is negative 4. So it would go down like this. Now, every point on this straight line, no matter where it is, and remember, a straight line extends forever and ever on both sides. There's no end. And every point on the straight line would fit into this equation. Therefore, there are infinite number of solutions for x and y from this equation. In fact, you cannot find the exact value of x and y from just one given equation. You need another independent equation to find x and y. If you think in terms of the graph, then the other equation would let you plot another straight line on this graph paper, and the point where the two straight lines meet would be the solution, because that's the only point that's a part of both straight lines or a part of both equations that would fit into both equations. We can discuss the graphical solution in another video, but the whole idea of this video is to show you how to solve equations by using the process of elimination. But remember, we need another equation to nail down the values of x and y. Let me just write that down. Method of elimination. Now this word elimination basically means getting rid of. So you want to get rid of one of the two variables, x or y. We will see how. I'll take the first equation as the one that we already discussed on the previous board. 4x plus y is equal to 18. Let's call this equation number 1. We need another equation to find x and y. Let's say the other equation we have is x minus y is equal to 7. Let's call it equation number 2. Now the whole idea of using elimination or getting rid of one of the variables is to make sure that the variable we want to get rid of has got the same coefficient on both the equations but with opposite signs. So if we want to get rid of x, we need a 4 and a negative 4 on both equations. If we want to get rid of y, in the same way, we need the coefficients of y to be the same with opposite signs on the two equations. And luckily, we already have it, because if you come to think of this, y is nothing but 1y. So we could say the coefficient of y is positive 1 on this one, and in the same way the other one has got a negative 1 over here. So they are the same number with opposite signs, and this is what we are looking for if we want to eliminate or get rid of y, so that we could just have an equation in x that's easy to solve, and that does have one single answer, not multiple answers. To be able to do that, we need to add the two equations. Now what exactly do I mean by adding two equations? I mean adding the left hand sides of the equal sign on both equations and equating them to the sum of the right hand sides of the two equations. Let me explain why this works. Let's say there are four persons A, B, C and D. And let's say the weights of A and B combined is 120 kilograms, and the weights of C and D combined is 140 kilograms. Now if I were to ask you to find out the combined weight of all four persons, you know the answer is 120 plus 140, which is 160. So what you have basically done is you have added the right hand sides of the two equations and equated that with the sum of the left hand sides of the two equations. That's exactly what we are going to do over here. So we have a 4x plus 1y minus 1y is equal to 18 plus 7, which is 25. Now this plus 1y and minus 1y, they would cross off to give you a 0. That's the whole idea. Get rid of one of the variables. There's no y anymore. We only need to deal with x. 4x plus x is 5x. 5x is equal to 25. Therefore x is equal to piece of cake. Divide by 5, you get x is equal to 5. Now once you get the value of one of the variables, it's pretty easy to find the other one. Just plug in this value of x that you have found into one of the two equations. Let's say I'm going to use the first equation. So we have 4 times x, which we know by now is 5, plus 1y or y is equal to 18. So 20 plus y is equal to 18. Subtract 20 from both sides, you get y is equal to negative 2. Therefore, the actual solutions to the two equations above is x is equal to 5 and y is equal to negative 2. Time for us to do a word problem maybe? The sum of the digits of a 2-digit positive number is 9. 4 times the tens digit is 1 more than 3 times the units digit. Find the number. So to begin with, there's a 2-digit positive number. We need to find the number. So therefore, we need to find the digits. Remember, this is the ones digit and this is the tens digit. It's given that the sum of the digits is 9. So let's say the number is x on the tens digit and a y on the ones digit. So it's given that x plus y is equal to 9. 4 times the tens digit, or 4 times x, is 1 more is equal to 1 more 1 plus than 3 times the units digit, 3y. These are our two equations, equation 1 and equation 2. Now as you can see on equation 2, it doesn't look like the equations that we had on the previous example, where the constants were on one side and the variables on the other side. If you want to use the method of elimination, you just want to make sure that all the variables are on one side. So you just got to rearrange the second equation and bring the 3y over to this side, so that you have 4x minus 3y is equal to 1. So that's just the other form of the same equation 2. So I'm just going to replace equation 2 with this form. Remember, they're the same thing. Now, like I said in the previous example, the idea of elimination is to pick one of the variables to eliminate, let's say y in our case, and make sure the coefficient of y is the same on both equations with opposite signs. Now on the first equation, the coefficient of y is 1. If you don't see anything, y means 1y. and the coefficient of y on the second one is negative 3. So if we want to make them the same, we want to multiply both sides of the equation 1. Remember, you are allowed to multiply both sides of an equation with the same number. Remember, we are looking for a 3 over here, a positive 3. Therefore, we are going to multiply this with 3, this with 3. We have 3x, rewriting equation 1, plus 3y is equal to 3 times 9 is 27. Another form of equation 1, just the same thing. Now I'm going to add up the left hand sides of the two equations. That's 4x plus 3x minus 3y plus 3y is equal to 1 plus 27. The whole idea of making the 3 and the 3 is to cancel these off, so that we have a 7x is equal to 28, which means x is equal to 4. Once we get a 4 over here, it's pretty easy to figure out the other one. It's given that the sum is 9 for the two digits. Therefore, the other one has to be a 5. So our number is 45.